Welcome class 9th and 10th. Today we will learn about force. A force is that important term, that important cause without which the whole universe, its existence is not possible. So what is that force? We will learn today. You know the formula for force, it is given by F equal to mass into acceleration. Every object has certain mass, then how will you define that what will be the force? In certain books it is written that force is only a push or pull. How will you give the correct explanation for that? If you apply the force on any object and it moves in the direction of force, okay, it is pushed. But if the same force is applied on any other object and it doesn't move, then what will you say? Look, what I am telling you, force is that cause which produces acceleration in an object at which it acts. And if any of the object is under the effect of two or more forces, still it doesn't change its position, then such set of forces is said to be balanced force. Similarly, if you apply two or more forces on an object and in the object a non-zero acceleration is produced, then such set of forces said to be unbalanced force. Look here, at the top of table, suppose there is a box, then gravitational pull of earth on the box, I will show this by the gravitational force is acting downward. Who is applying? Earth. And the table is applying the force on the box vertically upward. I am writing it with normal force. These both the two forces, normal and gravitational forces, they are equal and opposite. Object has net force on it is 0. And what is the state of the object? Stationary, rest position. We can say that if the object is under the effect of two equal and opposite forces and in the state of rest, there is net force on it is 0. We cannot say these two forces, although they are equal and opposite, but they are not the action reaction forces. You might have misconception, although action reaction forces are equal and opposite, but what is the difference here? Action reaction forces are the forces acting between the two objects in contact applied by one on other. Here earth is applying the force on the box vertically downward and table is applying the force, reaction force on the box vertically upward. So these are not action reaction forces. Action reaction forces are applied if you show like this, that this is the box, and if the box is applying the force on the table and the table is applying the force on the box in this way. So if you see that this is the force applied by table on the box and this is the force applied by box on the table, then these are action reaction forces. So learn the difference. Also, suppose this is the frictionless surface and air resistance is negligible, and if the any ball is moving continuously with the velocity v at this surface, can you tell any force is acting on it? Ball is coming with the same velocity and it is covering the certain distance, moving at the same surface. with the same velocity. Don't get confused that it cannot move with constant velocity without having any force on it. Look here, ball is moving with the constant velocity. You can also say that at every point the gravitational force and the normal reaction is acting on the ball, but still it is moving with the constant velocity in this direction. Net effect of force or net force is still zero. So don't consider that object at rest, it is not under the effect of any force, and object in motion, it will be moving under the certain force. This is the misconception. Learn always the force is only that cause which produces the acceleration in the body. Learn the effect of force. In both the cases, the net force on the body is still zero, whether it is at rest or it is moving with constant velocity. Constant velocity means the speed and direction of motion are not changing. So we have learnt so much about force. You must be knowing that force is m into a. Then how will you define the force and its unit? Unit is Newton. You know all this. If effects of force you see, then what are the effects of force? You know, the force can change the object's position from rest to the motion. Number one. Number two, the first one is rest to motion. Second, it can increase the speed of an object. Third, it can change the direction of the moving object. Also, if the object is non-rigid, then its shape can also be changed by applying the force. Also, one more cause, that force can rotate the object. Now we will learn this point, because in all these you can say that first three are the acceleration produced in the object. They are saying the same. How the acceleration is produced? If the object is at rest, you apply the force, it starts moving. Its speed increases or its direction changes. Now look, what are the effect of force? What is the effect of force if the object is rotating, starts rotating? You know, a rigid body, when force is applied on it, actually the two types of motion are possible. Look, first at the first level you will see, if the force is applied on an object, then it produces the linear motion. When the force is applied on the object moves in the direction of force, then it is said that object has linear or translational motion. What do you mean by translational? Means transfer of place. So translational motion. The other motion is rotational motion. What do you mean by this rotational motion? The object is fixed at a certain point. Suppose this is the object and it is fixed at certain point O. This is called pivot. Object is said to be pivoted at this point O. When a force is applied, suppose at this point M, and the direction of force is this one, then if you find the point of application M at which the force is applied, its distance from O, and suppose this distance is the perpendicular distance from the force. Look, I have written R. What is R? The perpendicular distance of force from the pivoted point. Then you know what happens if the object is pivoted, then with the application of force, object begins to rotate about a vertical axis passing through this fixed point, through this pivot, and this force produces, look here how this force is applied, then it will rotate the object about this vertical axis in the anti-clockwise direction. You can also produce the clockwise rotational motion if you apply the force in the reverse direction at the point M, suppose from this side. So, learn rotational motion of two types. Number one, anti-clockwise rotation. And what is this rotational motion? When the force applied on an object which is pivoted at certain point in such a way that object begins to move about this pivoted point through which the vertical axis is passing, so about that axis in the anti-clock sense. Similarly, other rotational motion is clockwise. Anti-clockwise and clockwise rotational motion, force is applied on a pivoted object. This whole explanation is said to be defined as moment of force or the turning effect of force. You know, linear motion, the force applied, object moves in the direction of force. But when the object is pivoted, then object is moving around the fixed point. So, the force, its effect is to turn the object about the pivot. This turning effect of force is called, is represented moment of force, or it is said to be torque, represented by the symbol tau. How will you find what is moment of force? Suppose in this example, then tau is represented by this r cross f. This is the vector quantity, this is torque or tau, this is moment of force, r is the perpendicular distance and the force applied here. You know these all three are vectors, and how the moment of force, its direction is calculated, it is determined. Look, if r and f are given here, and suppose you put the right hand thumb, by the right hand thumb rule you can determine the direction of moment of force. How? If the curling of the right hand finger, they are from the r towards f. Look, r cross f it is written, I am showing, suppose this is the r and this is the force applied f, and this is the angle theta. Look here, then r towards f, what is the thumb's direction? Upward. So, in this case, if the r cross f you have written, then the moment of force or torque is directed perpendicular to the plane upward. I am showing here if this is the torque direction or r cross f direction. If the clockwise, then you will find that it will be r. If this is r, this is f, then look, my thumb is going inward, perpendicular to the plane, inward. So, in this way you can determine the direction of torque. How will you find that this torque? Why should we learn this torque? What is the application of this torque? Look, the handles provided in the doors are far away from the fixed end of the doors, that is hinges. From the hinges, the maximum is the distance. If r is more, then with the lesser force, this turning effect can be provided easily. That means you can open the door easily. Similarly, if you have seen the wrench, if the wrench is there to open the nut, then it has long handle. Nut is placed here, the long handle means r is more, with the help of lesser force you can open or tighten the nut. Other example, you have seen that in the bicycle, you have seen the wheels of the bicycle has such toothed wheels are there, and the front wheel is bigger as compared to the rear wheel. Can you tell why? Both are attached with the chain. You must have seen this one. The paddle is here. What happens when the force is applied at the paddle? You know, bring this wheel size is bigger, lesser force. This R is more for the bigger size of wheel. So, lesser force produces the torque. So, you can easily run the bicycle with the applying lesser force on the front wheel. And what happens, since front wheel is attached with the chain to the rear wheel, then it will rotate in this direction, anti-clockwise direction. So, why this is bigger and it is attached with the chain, this is moment turning effect of force to make it easier. So, there are few examples by which you can learn the moment of force. What is couple? You know, moment of force can be, this is R cross F. You have just learned that with the application of one force, object is rotating. Actually, couple means to equal an opposite pair of forces. Okay. In this moment of force or torque, we have already discussed the effect of one force, but actually there are two forces. Here, if we have applied the force at this point M, but the object is fixed at point O, so there is a fixed reactionary force at the fixed point. Since its moment of force is 0, because this force, reactionary force, is not at a certain distance from the fixed point, it is acting at the fixed point. So, its moment of force or turning effect we don't write here, we write only this force into this distance. In the couple, look, how will you show? If there is an object, suppose this is the linear scale, its mass per unit distance is same, it is the midpoint. At this point you apply the force F, and similar amount of force is applied at the other point, other end, but in opposite direction. What I am talking about, this couple, equal and opposite force. Now, if this point is suppose M, this is O, this is N, how will you find what is the moment of this couple? Look, this force will have turning effect about this pivot fixed point O, this force will have turning effect about this point O, both are in the same direction. Look the rotatory effect. Then how will you apply the moment of force for first one? Then you will write F into OM. Moment of force for second one, you will write F into ON. What will be the net moment of force or moment of couple? You will write here, this is moment of couple. Then net moment of couple will be F cross OM plus F cross ON. What will be this? F cross OM plus ON, that is total N, Mn. So, this is the moment of couple. How you will define it is written, two equal and opposite forces acting on an object which is pivoted here. Then either of the force, its magnitude multiplied by the total distance between the forces. What is Mn? Both the forces are acting at the ends. So, this is moment of couple. Now, if the object is moving under the effect of forces, then we will learn that what is the equilibrium condition, that is the equilibrium of bodies. Look here, that equilibrium of objects. This is very important to know, that if the object is under the effect of two or more forces and the object remains at rest, or the object remains in linear or rotational motion, equilibrium conditions, what equilibrium positions of the object, as per this there are two equilibrium conditions. Number one, two types of equilibrium. Number one is static, number two dynamic. You know, dynamic means in motion, dynamic or kinetic word. Static equilibrium, how will you define it? If the object is at rest under the effect of two or more forces, then it is said that object is in the state of static equilibrium. How will you write the condition for this? Suppose you write this word is sigma, that sum of all forces is 0. What is example of a static condition? Any of the object you have seen here, this one object is at rest under the effect of its weight and reaction. You can also say that if you take any object, you apply the force from this side, same force on this side. This is the state of equilibrium. What about dynamic equilibrium? If object is in the continuous state of linear motion or rotational motion under the effect of several forces, then it is said that object is in the dynamic equilibrium. Dynamic means in motion. What type of motion the object can have? Either linear motion or rotational motion. So, under the effect of so many forces, it should not change. What? Linear or rotational motion. Then it is said dynamic equilibrium. What are the conditions for equilibrium? Then we can write, this is the first condition, static one you have written, and the second condition for in general equilibrium of objects, since equilibrium of two types, then you have to write that the sum of all moment of forces, all should be 0. You can write here this R cross F, this should be 0. This sigma, this means all forces which are acting at several distances, their product and summation, addition should be 0. R1, F1, R2, F2, R3, F3, 0. This is the equilibrium of objects. Now, what is principle of moments? Finally, we discuss this. What do you mean by principle of moments? This principle of moment is nothing, it is you have experienced in daily life. Suppose this is the beam balance. If you apply the certain force here, suppose this is F1, then to remain the balance, this beam horizontal balanced, equal amount of force must be applied at the equal distance from this fixed point P. So, if this is the force F2 applied at the distance, suppose this distance is R1 and this distance is R2, this will produce turning effect in this direction and the F2 will produce turning effect in this direction. What will you say? Simple. What is principle of moments? Net turning effect must be 0. How? the anti-clockwise moment of force should be equal to clockwise moment of force, only then the beam will remain horizontal. So what is principle of moments? It simply says that if an object remains horizontal balanced, then the net moment of force acting on it should be 0, or the net anti-clockwise moment should be equal to net clockwise moment. We have seen the effect of force, how it is used in numericals. Look, conceptual numerical I am taking about this wheel, and this is the pivoted point of wheel at the center. This is the from where the axle is passing. At this point, suppose its name is A, the force is applied F1 in this direction. Question is, suppose at this point P, what a force is applied, find its magnitude and in what direction it should be applied so that wheel doesn't rotate. You know, this F1 is applied at this direction. How will the wheel rotate? This is the fixed point O, then the wheel will rotate about the vertical axis passing through fixed point in this direction. Question says it should not rotate, then any of the force which will have the opposite effect of the F1, it should be applied. Clear? The force at P must act downward so that its rotational effect is opposite to the first one. So this is the force F2. What is the answer? It should apply from the point P vertically downward. Next part is asked, which will be bigger? Principle of moments we have learned. Look, net torque, net moment of force should be 0. So what will you write here? This is F1, and what is this F1? Perpendicular distance OA. So F1 cross OA. And what is this? Clockwise. Clockwise rotation is this moment of force is written with negative sign. So you can write this with negative. What is this? Anti-clockwise. And what is F2 into, suppose this point is O dash, then you know F2 is acting from P, but its line of action at the perpendicular distance O dash. You will consider the perpendicular distance from the line of action of force. Then never join this with this and you take only this OP, because this is not the perpendicular distance from the pivot to the force. Always perpendicular distance is considered. So look here, this is O dash. Then what will you write? This will be plus F2 into O dash. This must be 0. You can write that F1 into OA equal to F2 into O dash. When it will be same? Look here, OA is greater than O dash. This product is to remain same. Therefore, F2 will be larger because O dash is lesser. So, two questions were asked. What is the direction of force and what is the magnitude? You have seen direction of force is to oppose the object in such a way that it produces the moment of force in the opposite direction. And what is the distance, perpendicular distance, that is lesser in case of F1. I hope you must have understood this concept. By learning this concept, there are several questions you can solve. Thank you.